Alrighty, we're doing 7.5 today, and it's rationalizing denominators. Now, what does rationalizing mean? Rationalizing a denominator means to get rid of the root. So, and you want to make it rational, meaning not irrational. Irrational is when you have a square root. So to rationalize it, you just do what it takes to get rid of the square root. In this case, this is the square root of 2 is on the bottom. So how do we get rid of it? Now, let's just multiply by square root of 2. What do we do the bottom? Do the top. And then what do you get? You get, on the bottom, square root of 4. Or, and what's the square root of 2 times the square root of 2? You get 2. On the top, you just get the 3 square root of 2 together. So that is your final answer. Here's another example. 4 over the square root of 2x. Again, we want to rationalize the denominator, which means get rid of the root and make it just like a normal fraction on the bottom. Basically, you're just putting it on top. So the way to do that is just multiply whatever it is. And what it is? Just the square root of 2x. Dun, dun, dun. And then what do you get? Dun, dun, dun. You get, well, the square root of 2x times the square root of 2x is just 2x. You can go right for that whenever you do it times itself. And now on the top we have 4 times 2 square root of x. Now what happens here though is, oh, I can reduce that just a wee bit by canceling out 2. So the final answer is 2 square root of 2x all over x. Can't cancel those x's out because one's under the square root and the other one isn't. And that's about it you can do with it. So that's further. Let's move right along. What if it's a cubey? The bottom has roots, but it's a cube root. How are we going to rationalize that? Well, here you can't just multiply by the same thing because it's not square, it's cube root. So you do whatever it takes to complete the cube. Now, 9 is not a perfect cube, but 27 is. So if we multiply this by the cube root of 3, that'll give you the cube root of 27. That'll be cool. And we want to make the x squared into a perfect cube, which basically means x cubed, so it needs another x. This is a little trickier to determine, but it's you're making perfect cubes. Whatever you do to the bottom, do to the top. And then, what do you get? Well, on the bottom, we get the cube root of 27x cubed. Nice. On the top, those are all cubey stuff, so slam it all together, 6xy squared. That's okay. That's fine with me. And then for the grand total of, on the top, we got just that cube root of 6xy squared. I doubt anything's canceling there unless something very nice comes out on the bottom, but not that nice. I mean, it works out nicely. You get the cube root of 27 is 3. Cube root of x squared is x. There you go. Although that's free, rational. It is rational, the denominator here, isn't it? Because it doesn't have a root in the bottom. You basically shifted it on top, or all the roots are on the top. Okay? It's cool. Next up is something even a little more complicated, where you got your roots in the bottom, but it's a binomial, so it's two things. So I can't just multiply by itself, because you'll have to FOIL it out, and then you won't get rid of it that way. So what you got to do is multiply by its conjugate, they call it. So since this guy looks like that, what you can do is multiply by practically the same thing, but make it minus. Whatever you do to the bottom, do to the top, boom, boom. And then, what is the bottom equal to? Pray tell. And what is it? Well, when you do your FOIL deal, you get the square root of 2 times the square root of 2. Well, that's the square root of 4, or just 2. Square root of 2 times minus the square root of 5 is minus the square root of 10. And the square root of 5 times the square root of 2 is plus the square root of a 10. Nice. And then last but not least, minus the square root of 25. This is all on the bottom right now. I don't want to worry about the top yet. And then you get 2 minus square root of 10 plus square root of, all gone, minus 5. This is on the bottom. Let's go to a fresh page. So coming back to this, you can see this was on the bottom, and then this is on the top. But this is a little messy, so let's go to the next page. Boom. And that's what's left. Oh, we can work the bottom out a little more. So you get 2 times the square root of 2 minus the square root of 5 over 3. Is that good enough? That seems pretty good. But if you want to take it one more step and multiply the numerator out, you get, well, what do you get? Well, you definitely get a minus on the bottom. So that one slipped by me. But so if you wanted to multiply that out, you get 2 square root of 2 minus 2 square root of 5. Notice the 2 is just hanging out in front because it's not, this guy is not a square root or anything. He's just the number 2. So you double the square root of 2, double the square root of 5 with a minus between, all over minus 3. Good enough? Yeah, the answer could look like this. You should say, let me take care of that negative, and I'll make this minus and this plus. So if you wanted to do that, they're all equivalent. Okay? Well, that's about the size of it. You know, of course there's more little complications, but I think you have all the powers you need. Sometimes we rationalize the numerator also. We don't really have to do that very much, but every once in a while you just play around with it. And just do the exact same thing. Multiply by the whatever the root is, square root, or multiply by the conjugate if it's a binomial, or if it's a cube, perfect cube, or not so much a perfect cube. You want to make it a perfect cube. If it's a cube root or fourth root, you want to multiply by something that'll, then you can take the cube root or fourth root of and it comes out to a nice whole number without that. All right, and that's that. See you later.